Let's say this is 8255. 8255 is having three ports, namely port A, port B, port C, and it has data bus. This data bus connected to the microcontroller or microprocessor. Let's say this is 8051. This 8255 is used to expanding the port. Though 8051 having four ports, still you can extend the ports by means of connecting additional 8255. So I have connected this data bus with the data bus of 8051 such a way that I have expanded three ports. Now what I have done here, I have connected 8 LEDs, right? 8 LEDs are connected in port A, and 8 switches are connected in port B. As well, the switch is connected with LED also. So what happens when I give any input to this port B, I can see it in LEDs also. As well, what is giving the port A, that is also I can see it in LEDs. Try to understand, port B is having switches and LEDs. So whatever I press the switch, whatever the status I give in the switch, that I can see it in my anacri by means of this LED. As well, the data goes in 8255. I do some arithmetic operation on this 8051 by receiving this, and I send it out to port B, port A. So what I have done, I need to configure, this is bidirectional by default, I need to configure port B as an input port, port A as an output port. So it has some control word, is a register. This registers whatever you do, that makes the connection of this and this. If you want to make port A output, it makes this bus to this bus such a way that it comes to this, and port B input, it is the connection, something connected like this. So you need to write appropriate control word. For control word, this is the format, correct? This is D0 for making port C lower. The port C is split by two port C lower and port C upper, where the port C lower nothing but port C lower 4 bits, right? So this D0 for configuring port C lower 4 bits are input or output. If you make this bit to be 1, the entire port C lower become input port. If you make this bit to be 0, the entire port C lower becomes output port. And D1 for entire port B, input or output. And mode selection, whether it is conventional mode or some special mode. So by default it is mode 0. So these 3 bits like in group B. Coming to this, D3, D4, D5, D6, these 4 bits are in group A, where the D4, this is D4 for port C upper 1 or input or output, and D5 and D6, sorry, so I have a little bit confusion, correct. D3 for port C upper, input or output, D4 for port B, whether input or output, and D5, D6 whether mode 0 or mode 1 or mode 2. What happened, by default you select for mode 0, correct? And these sets and all, D3, D4, D5, D6 together group A we call. And the D7 by default it is 0 for conventional mode 0, so you make it to 0 and you work it out for this. So you have the control word, right? This control word to be written in this registers. You frame the control word and fill it in this. What you need to do, here you have to refer the control word format as such I have given in this picture. So this one you need to write it in this, right? Then formulate the control word for making port A output port and port B and port C are input port. So what you can do in this, right? And you read port B, do some arithmetic operation and send it to port A. That is what the object of this. Right now what they have done, read port B, complement it and send it to port A. So that is what you have seen in your experiment. So here the address and all you should know that, right? What is the address of port A, port B and port C, and for control word? The address for port A is E8 the port A address is E800, which is connected in your trainer kit, which could be anything, but what the trainer kit we have in our lab is being connected like that. Port B E801, port C E802, and the control word is E803, which is mapped in external data memory. You have to consider those 4 memory as an external data memory. So you have to use the instruction called MOVX. So by doing this, and I can access individually. This is connected something like mapping, like memory mapped IO. Memory mapped IO. In the sense you are accessing IO by means of memory. As a memory you are accessing it. So this address is E800, E801, E802, and control word to configure your ports and all E803. So you can work it out. Remaining things and all you can discuss in lab.